Hello to everyone. I am Dr.R.Radha, Assistant Professor of PG and Research Department of Chemistry. Today we are going to discuss about the solid state chemistry, mainly discuss about the crystalline systems. There are 7 crystal systems are there. We discuss about the 7 crystal systems. The learning objectives are to understand the concept of 7 crystal system and to know about how to memorize all 7 crystal systems with examples and their lattices and cell dimensions, and then to learn about the importance of crystal systems. So, introduction about the solid state chemistry. This is a branch of physical chemistry which deals about the structure and properties of solid states. There are 2 types of solids are there. First one is the crystalline solid, then the second one is the amorphous solid. This is the diagram of the crystalline solid and amorphous solid. These are the properties of the crystalline and amorphous solid. There is some difference are there. In crystalline solid, there is arrangement is ordered. In amorphous solid, there is no ordered arrangements. It is in crystalline solid, the anisotropic nature was found. In amorphous solid, the isotropic nature was found. In crystalline solid, the sharp melting point was observed. In amorphous solid, no such sharp melting points. In electrical and thermal conductivity for the properties of the crystalline solid are having. In amorphous solid, that conductivity of electricity and heat are not observed. This is the law of constancy of the interfacial angle. What is the interfacial angle? The angle between the 2 axes, that is called the theta, is interfacial angle. This law states the angle between the adjacent corresponding faces of the interfacial angles of the crystal of the particular substance is always constant in spite of different shapes and size of the mode of the growth of the crystals. And one more law for the crystalline solids are the law of rational indices. This law states that the ratio of intercepts of different faces of a crystal with the 3 axes are constant and can be expressed by the rational numbers that the intercepts of any face of the crystalline along the crystallographic axis are either equal to unit intercepts, that is A, B, C, or some simple whole numbers multiples of them are founded. And these are the elements of symmetry observed in cubic crystals. One is a rectangular plane of symmetry. It is found in the cubic system for 3 rectangular plane of symmetry was observed, and a diagonal symmetry, the diagonal plane of symmetry, that is 6 diagonal plane of symmetry was observed in the cubic crystals. So, elements of symmetry is cubical system. There is 13 axes of symmetry was found in the cubic system, which is shown in the presentation. So, these are the simple 7 crystal system named cube, tetragonal, orthorhombic, monoclinic, triclinic, and hexagonal and trigonal. These are the example for that the corresponding crystal system. The cubic system was found in the fluoride, and the tetragonal systems was found in the wolframite, and the orthorhombic system was found in the tanzanite, and the monoclinic system was azurite, and the triclinic, amazonite, hexagonal in emerald, and trigonal was found in the rhomboclinic systems. So, these are the name again, once again I repeated, and cubic, trigonal, monoclinic, orthorhombic, tetragonal and trigonal, hexagonal are the 7 crystal, basic 7 crystal systems are found in the crystalline nature. And the interfacial angles are shown in the figure. For the cubic system, A is equal to B is equal to C, and then interfacial angle alpha is equal to beta is equal to gamma is equal to always 90 degree. In tetragonal system, alpha is equal to beta is equal to C, but it is not equal to C. In the interfacial angle of tetragonal system is alpha is equal to beta is equal to gamma is equal to always 90. In orthorhombic system, alpha is not equal to beta, and also beta is also not equal to C. And the system, the interfacial angle of alpha is equal to beta is equal to gamma is equal to 90 degree. In hexagonal system, we found the angles are alpha and beta and are equal to 90, but the gamma value is some different 120 was observed. In monoclinic system, alpha and gamma have the same value 90, but beta is different, 120 was observed. In tetraclinic system, it is a highly unsymmetrical system. So, the phases value alpha, beta and theta is always not equal to other angles, and also alpha, beta and gamma is also it not same as 90 degree. So, in crystal system we have observed the number of lattices in the corresponding crystal system. In cubic system 3 lattices are Bravais lattices are observed. In tetragonal system there are 2 Bravais lattices are observed. In orthorhombic 4. In monoclinic 2 and triclinic was trigonal and hexagonal, always respectively the number of lattice in the system is 1. And for the 7 crystal system, we have observed the many more examples are there. For the cubic system, sodium chloride and cesium chloride was the best example for the cubic system. For the tetragonal system, the ammonium bromide NH4Br was the example for the tetragonal system. For the orthorhombic, calcium carbonate was observed as a great example for the orthorhombic system. For the hexagonal system, silver iodide and silicon carbide was the example for that crystal system. So, these are the simple Bravais lattices are given for the 7 crystal system. For the cubic, mainly cubic, for the simple cubic and body centered BCC was observed. In the cubic system, simple cubic, body centered cubic and face centered cubic was observed. In all the crystal systems, we have observed the simple primitive system in the in all system are observed. So, summary, the crystal systems are a way of categorizing crystals based on the length, angle of the axis, whereas the imaginary lines that define the crystal shapes. These are the 7 crystal system. What are that? Cubic, tetragonal, trigonal, orthorhombic, monoclinic, triclinic and rhombohedral. Each of the system having the unique character is determined by the symmetry of the crystalline lattice. For example, cubic crystals having the axis of equal length at the right angles to each other, while hexagonal crystals have 3 equal angles at 120 degree angles with a 4th axis perpendicular to the other 3. These are the system provides the framework for understanding the geometric properties of crystals and are essential to mineralized and materials scientists studying for the structure and properties of these crystal systems. So, thank you for visiting.